This is part 5 of Wallace Thornhill's Proto Saturn, Saturn as a Star series. Enjoy.
That's why the star, the dim star, Sirius B, is brighter in X-rays than Sirius A, because the corona emits X-rays. So, what is a brown dwarf? To summarise, a red or brown dwarf can be characterised as an independent gas giant type object under low electrical stress from its galactic environment. A main sequence star is electrically stressed, so it resorts to becoming a tufted anode, which, as I said, regulates the output of the star. This is why all bright stars appear to twinkle. They don't change from day to day. Red giants are normal stars under low electrical stress. White dwarfs are stars with a low luminosity coronal discharge only. Is that at the same point? Yeah, red giants are normal stars under low electrical stress, and white dwarfs. So, size matters. Brown dwarfs come with a major drawback for astronomers. Their stellar radii are hard to determine accurately. In the electric universe, brown dwarfs are not dwarf stars. Instead, all red stars have a bloated, glowing anode sheath which expands and contracts in order to collect the amount of electrons required for that discharge. As the anode sheath grows, its electric field grows, which results in the prodigious and unexplained stellar winds from cool red giants. If the winds were due to the heat of the corona, then this puts paid to that idea.
Most stars twinkle because there's an atmosphere between us and the stars, and the pockets of air moving up and down through the atmosphere causes them to twinkle. Brown dwarfs and red dwarfs are completely different things. Red dwarfs, most of them have planets orbiting around them, so you can determine the mass of them, and they're a lot more massive than a lot of brown dwarfs, or at least a little bit more massive than brown dwarfs. So there's actually no evidence towards his theories, and the reason why small stars are more active is because they don't have as much gravity to keep things from flaring out or escaping from the surface of them. So size does matter, and we have a fairly good idea how massive these objects are. Again, he just lacks a lot of evidence. Now we'll go back to Wallace Thornhill.
In a December 2008 NASA report, the brightness of a brown dwarf at 17 light years distance was twice that expected for a brown dwarf with its particular temperature. The solution? The object must have twice the surface area, they said. It must be twins. Such ad hocery is unnecessary in the electric universe model. A brown dwarf's photosphere is much larger than the standard model of such stars predicts. The cradle of life. And this gets back to the idea of the Garden of Eden period in man's memory. If you're a satellite orbiting within that anode glow, and this is not an outrageous idea because astronomers have suggested the same thing for red giants, that planets could actually orbit within that star because the atmosphere is such low density. In fact, we orbit in the sun's atmosphere, if you like, and it doesn't cause us any trouble. But within that glowing shell, the radiant energy received from that envelope is constant over the entire globe. The light from the plasmasphere is not reflected light, it's radiant energy. Brown dwarfs radiate blue and ultraviolet light even though they are cool at a temperature around 950 K. This is further evidence that we are looking at a mix of an electrical red anode glow and coronal ultraviolet blue end of the spectrum. There are no seasons, no tropics, and no ice caps. A planet does not have to rotate, its axis can point in any direction, and its orbit can be eccentric, and you'll still get this beautiful, even temperature over the whole body. The radiant energy received by the planet will be strongest at the blue and red ends of the spectrum, so photosynthesis, which relies on red light, would be very active. The skylight would be a pale purple, which maybe is referred to by the classical purple dawn of creation. And I know that in Canberra we have this new arboretum, which is fantastic, and all of the new trees that are being planted are put in red plastic to start with. And I asked the head of the arboretum why they did that, and he said the plants grow much better in red light. Water molecules dominate the spectra of brown dwarfs, so you want to know where the Earth's water came from? The light on Earth was dim and purplish amid a continuous mist of water. No other bodies in the system were visible. And this is what Dave mentioned yesterday. This explains the abundant water on Earth and many satellites of the gas giant planets and the rings of Saturn. And the red light, warmth and water was ideally suited for giant ferns. It explains the gigantic lush vegetation found at the poles, fossilised as coal. Now, the problem faced by life on planets orbiting a red star, I think you saw last night, which was this flaring red dwarf. So this tendency to flare up is a problem. The reason for this is that, as I said, the red stars don't have the current regulation afforded by the bright photosphere. So the response of a red star to a sudden electrical disturbance in their environment is to shed charged matter in a flare-up. They may also change in apparent size as the anode glow accommodates to the electrical environment. I think this would account for the great dyings in the geological record and the episodic deposit of vast sediment and mineral layers on the Earth, and on other bodies too. Every body that's been looked at is layered. What's more, it explains for the first time the oceans of salty water on Earth. Comets cannot be responsible because they have little or no water and little or no sodium chloride. Now, just see how much of this I want to show you.
In our past on the planet, there have been different periods where there's been different atmospheric compositions, where there's been more carbon dioxide, which allowed for more warmer temperatures. That's why you have giant ferns and stuff storing away carbon that became coal and oil and all that stuff. It had nothing to do with being inside a star's atmosphere. And if you're inside of star's atmosphere, there wouldn't be any water because it'd be evaporated out, because even in a cool star, it's still a few hundred degrees Celsius. So it being inside of an atmosphere would be kind of pointless. Planets, the rocky cores of planets probably exist inside of stars, but not ones with atmospheres and water. And comets do produce do have water. We have spectrum of comets that have water in them, and I'll have a few of them overlaid in a second here. Well, they don't actually have water. They have OH, or I can't think of the name of the hydroxide, which is water with one less hydrogen on it, and that shows us because the hydrogen gets stripped off by the solar wind. Need it? Okay, and as I said, the flares it's not electrical stress, it's the gravity and the magnetic fields and stuff can't hold the flare in, so it easily escapes off the sun, off the star. But this is just speculation, and I have no evidence, but I don't like their evidence kind of fight. So that's basically most of what this is. But just a second. Okay, here's 3 spectrum of 3 different comets. Comet Hakataki, C1996. can't think of what can. B2. Well, I remember actually seeing Hakataki. I was doing telescope tours at the time. It was actually a fairly big comet, that and Hale-Bopp. But you can see that there's a big spike around 3,000 angstroms. But you can see there's a big spike and it says OH, and that's the hydroxide, which is OH, and with one less hydrogen. And here's one of 2002 comet linear. You can see another couple good spikes of the hydroxide ions, and then the final one is comet 238P, which is in the main belt, and it also shows water. And the last one's taken by the James Webb Space Telescope, and you can see water. Okay, in the last segment here, he talks about SETI and how the reason why they haven't picked up a signal is because the plasma of the sun envelops us is preventing a signal from coming through, and that stars about astronomers think that planets orbiting red dwarf stars would be good candidates for life. Actually, because of the flares, a lot of people don't like red dwarfs for life-bearing planets. But they are, red dwarfs can last trillions of years compared to billions of years. Well, no. They last a lot longer because they slowly consume their nuclear fuel. Okay, and this is finally the 238P Reed comet, and you can see there's a signal for water in it. Okay, I'm going to let him talk for a couple minutes and then wrap this up.
This raises an interesting side issue, and that is, ironically, intelligent life can't communicate through such a plasma shell using radio waves. So the lack of intelligible radio signals in the SETI project is understandable. In fact, denizens of such worlds would most likely be unaware of the universe at large. Now, astronomers also submit that orbiting a red dwarf is possibly one of the best places to look for life. What they've never considered is orbiting inside a red dwarf.
Okay, this is about halfway through his presentation. I'll probably do some more later on, but this is the end of part 5. I hope somebody found this useful and educational. It's not wrong to have alternate theories, but you have to have the evidence to back up the alternate theories, and the electric universe just doesn't have that. So I hope everybody has a good day, and goodbye.